Optimization. Here is an example. What is the largest possible area for a right triangle whose hypotenuse is 5 centimeters long? To answer this question, we'll look at a right triangle. We know that the hypotenuse is 5 centimeters long. The other sides, which are referred to as its dimensions, are x and y. We know that x squared plus y squared has to equal 25, no matter what x and y are. And to find the largest possible area, we're going to state the question by writing maximize A for area, which is for a triangle 1/2 the base times the height. X and y are the base and height because they are perpendicular. This equation up here, x squared plus y squared equals 25, could be solved for either x or y. It doesn't matter which one. If we solve for y, y has to equal the square root of 25 minus x squared. So if we replace the y in this equation for the area will be a function of x, because it's 1/2 times x times y. And now we're going to find the derivative of this. In class a while ago, when we were learning about the product rule and the chain rule, we had a warm-up exercise, which was to find the derivative of this. So you should try doing that again, try to find the derivative of this again. And if you need help, go back to your notes and find where you did this. We did it in class. And you'll find that the derivative of this, after a lot of work and simplifying, comes out to be 25 minus 2x squared over 2 radical 25 minus x squared. Takes a while. It's the product rule plus the chain rule is in there. Now we're going to find the critical values. The critical values are when the derivative is 0 and when the derivative does not exist. The derivative is 0 when its numerator is 0. And that's when x squared is 25 over 2. And that would be when x is plus or minus the square root of 25 over the square root of 2. The derivative does not exist when the denominator of the derivative is 0. And that's when x is plus or minus 5. So there are actually 4 critical values, because there are 2 values of x that make the derivative 0, and there are 2 values of x that make the derivative not exist. And we're going to make a chart with A, that means the area of the right triangle, a prime, the derivative of a, and x. So the nice thing about a word problem like this is if there's any x before 0, we don't need to consider, because x is a side of a triangle, and the side of a triangle is not ever a negative number. Also, in this problem, if x is 5 or more, we don't consider any of those x's, because since the hypotenuse is 5, x cannot be 5 also, or more than 5. The hypotenuse is always the longest side of the triangle. So of all these critical values, the negative ones are not important. The side of a triangle cannot be negative. And 5 is also not important, because x cannot be 5. This side can't be 5 if the hypotenuse is 5. So we really only care about the positive 5 over radical 2. Wherever that is, a prime is 0 when x is this number. Now we pick any number between 0 and 5 over radical 2, plug into a prime, and you'll see that you get a positive number. You should take the time to plug it in, verify that. Pick a number between 5 over radical 2 and 5, plug into a prime, and you'll get a negative number. It takes a little bit of time to figure those out. You should make sure you do that. When a prime is positive, a is increasing. When a prime is negative, a is decreasing. So a, which means the area of the triangle, is maximum for this x value right here. The area of the right triangle is maximum when x is 5 over the square root of 2 centimeters. Y equals some number, we'll figure it out in a minute. And on your AP Calculus exam, when you have to give a reason for this answer, to justify this answer, it's required that you write these words: because a prime changes from positive to negative at x equals 5 over radical 2. So these are exactly the words needed on the AP Calculus exam for justifying your answer. Area is maximum at this x value, 5 over radical 2, because a prime changes from positive to negative at x equals 5 over radical 2. To finish this problem, we get the y by going back over to right here. Put 5 over radical 2 in place of x. That tells what y equals, which is this side of the triangle. And coincidentally, that comes out to be 5 over radical 2 also. I did these ahead of time to save time, to shorten the video length. And the largest the triangle can be is, go back here, whatever 1/2 times x times y is. The largest possible area, this is the question, the largest possible area is the area of the triangle is 1/2 the x times the y, the base times the height. This is the base of the largest possible area, and this is the height. That's numerator is 25. Radical 2 times radical 2 times 2 is 4. And since this number is centimeters and this number is also centimeters, this area is centimeters times centimeters. We say square centimeters. So that's it. We've answered everything. And we're going to do one more example of this kind of problem called optimization. A 216 square meter rectangular pea patch is to be enclosed by a fence. So there's a rectangular pea patch, and this black border is a fence. It's going to be divided into 2 equal parts by another fence parallel to one of the sides. Perhaps like this. There's another fence. But it said 2 equal parts, so I'll try to make it right in the middle. What dimensions for the outer rectangle will require the smallest total length of fence? Smallest total length of fence. First, we're going to use the fact that this entire pea patch is 200 square meters. So if this, well, let me do this. Let's say there's X here and another X here. And suppose there's Y here and Y here. The total, oh, so this red fence here, that would also be Y. The area here would be this side of the rectangle, which is X plus X, times this side of the rectangle. That has to equal 216 square meters. 2x square meters times y square meter, 2x meters times y meters has to equal 216 square meters. And smallest, so we're going to write this is the problem. Minimize the length of the fence. I'll use F for the length of the fence. The length of fence that's here is 1, 2, 3, 4x meters plus 1, 2, 3y. Now the equation 2xy equals 216. Solve for either x or y. It doesn't matter. I'm going to solve for y. Y equals 216 over 2x, or 108 over x. That means the y in this equation here can be replaced with 108 over x. So the amount of fencing needed will be just a function of just x, because it's 4 times x plus 3 times 108 over x. So this is a function of just x. That's the same as 4x plus 316. 324 over x. We find the derivative of this. Well, before we find the derivative, rewrite this as 4x plus 324, x to the negative 1. Now we can find the derivative without having to use the quotient rule. F prime of x equals 4 minus 324, x to the negative 2. And now we're going to find the critical values. Critical values are when the derivative, this is the derivative, is equal to 0. Also when the derivative is not existing. If if we solve this for x, I'm going to add this fraction to both sides. Cross multiply 4 times x squared equals 324 times 1. Divide both sides by 4. So x equals plus or minus 9. And 0 is also a critical value because the derivative, this is the derivative here in the yellow, does not exist when x is 0. So it's 3 critical values. 9 and negative 9 make the derivative 0. 9 or negative 9. 0 makes the derivative non-existent. We write f, that's the amount of fence that's needed, f prime, and x. Well, we know the x in this problem will not ever be a negative number. So we don't really care about this critical value. And when x is 9, f prime is 0. If x is negative 9, that's a critical value we don't care about because a side of a rectangle cannot be a negative number. So we only care about the 9. If x is smaller than 9, like 1, the derivative is negative. If x is bigger than 9, like 10, the derivative is positive. I'm plugging into here. So when f prime is negative, f is decreasing. When f prime is positive, f is increasing. So I can see that f is minimum when x is 9. The amount of fence needed is minimum, or I could use the word smallest. Smallest or minimum, same thing, when x is 9 meters. Because, here's how I know. I'm going to write how I know. F prime changes from negative to positive at x equals 9. These are the words required on the AP Calculus exam. The words have to be there. They come right from this picture, but it's required to write the words. The fence is smallest, or minimum, when x equals 9 meters, because f prime changes from negative to positive at x equals 9. So x is 9 meters. When x is 9 meters, y is, go up to here to find what y equals. Y is 108 divided by x, which I believe is 12 meters. All right, so let's make sure we read the question again and answer it. What are the dimensions of the outer rectangle? The outer rectangle, this side of the rectangle, is 18 meters, and this side of the rectangle is 12 meters. So that answers the question. What dimensions for the outer rectangle will require the smallest total length of fence? How much fence will be needed? Well, the amount of fence needed is going to be right there. The amount of fence needed is going to be 4 times x. That's 9. That's x plus 3 times y. It was y. That was all fence. That's a total of 72 meters of fence needed.